Okay, so there's actually a much faster method to get to the same answer as what we did in our previous calculus from first principles unit. Okay, so previously we did, okay, we got the point x and we got the point x squared plus 3 or whatever, depending on what our curve is, and then we do x plus h, and so we turn that x into a x plus h. Okay, and then we can use this to find out what is the gradient function at any point, and then we can sub in x can be equal to anything 1, 2, 3, negative 2, 18, negative 26 to find out what our gradient is at that point. But there's actually a pattern that starts to emerge, and the pattern looks like this. When we have y equals x squared, our derivative, which we also write as dy dx, winds up being 2x. And if we have y equals x cubed, our derivative, which we also write as dy dx, winds up being 3x squared. And if we have y equals x to the negative 2, our derivative winds up being negative 2x to the negative 3. So a pattern starts to emerge here. What is the pattern that starts to emerge is very interesting. The emerging pattern can look like this in a general form. If y equals x to the n, then dy dx equals n x to the n minus 1. In other words, x3, y equals 3x to the third, x to the 3. Okay, this one, in other words, this one comes down the front, and then this one stays there but goes 3 minus 1. Okay, it just minuses. Okay, so the 3 comes down the front, and this minuses 1. So dy dx equals 3x to the 3 minus 1, or 3x to the 2. Okay? So the power comes down the front and reduces itself by 1, or minus 1 from it. You can do this with anything. With any of these, they're all reduced by 1 and the original power goes down the front. You can even do it if you have a number out the front. Okay, let's try y equals 3x to the 6. Okay, it's going to be dy dx. The 6 comes down the front, multiplies by that 3. It equals 18 x to the 5th. Okay, so the same pattern emerges every single time. This is the quick method. Now you can do this with multiple, with a polynomial with multiple terms. So perhaps you have y equals 3x cubed plus 2x squared plus x. Okay, we can, and let's go plus 1. Okay, so we will derive each of these individually in this rule here. Okay, so we use this rule and we apply it to this one, and then we apply it to this one, and then we apply it to this one, and then we can even apply it to the constant term. Okay, so let's have a look. Dy dx is going to equal 3 comes down the front, multiplies by that 3, 9x, that minuses by 1, to the power of 2. Okay, plus 2 comes down the front, multiplies by 2, becomes 4x. 2 minus 1 is 1 to the 1, which is just basically nothing. Okay, x to the power of 1, 1 comes down the front. Okay, 1 minus 1 is 0, so x to the power of 0 is 0, so it's just 1. And this one here is kind of the same as 1x to the power of 0. 0 comes down the front and just becomes 0. Okay, so dy dx will simply equal 9x squared plus 4x plus 1. That is the derivative of this. Okay? So we can use it if we have multiple terms. We can even use it if we have negative powers, as we had a look up there. Okay, what if we had y equals 3x to the negative 2? We can even have it if we have minuses in our equation. Minus x squared minus x to the negative 3. Let's try this one. Dy dx, which is how we write our derivative, equals negative 6, because that negative 2 comes down and multiplies that 3, negative 6x minus 1 is negative 3. Okay, negative, this comes down the front and becomes 2. Okay, x, and this one minuses 1 to the 1, which is the same as negative 2x. Okay, negative 3 comes to the front, that multiplies by the negative, so it becomes plus 3x. Okay, this minuses 1 to the negative 4. Alright, so we can do whatever, any of these terms, we just individually apply this rule to them, and we can derive them. Okay, so that's really, really convenient. If we don't have, there's a few rules that we need to be able to apply before we can do this. We have to have terms by themselves. That's a really important one. And we have to have no x's in denominators. Okay, so there's a few things that we need to do to prepare. I'm just going to have a quick look at preparing on my next video.